So today we're going to talk about the life cycle of stars. So previously we've talked about that the universe is filled with galaxies, and in galaxies there are billions of stars. Well, there are also many nebula. Now remember, the nebula is this collection of dust and gas, such as hydrogen and helium. It is enormous in size. When we talk about the nebula, we talk about that this is the birthplace of stars. So in a nebula is where a star would begin its formation. Now remember, not every nebula becomes a star, but every star had to come from a nebula. So the way it begins is nuclear fusion. So that hydrogen and helium start fusing together to generate energy. So by definition, a star is a large ball of gases that can make its own energy through nuclear fusion. Now that process of fusion is that hydrogen and helium, where they start bonding together and fusing together, we start generating energy and generating what we consider the heavier elements. So this is where you start getting the lithiums and up through the irons developing. Because nuclear fusion generates a lot of energy, that star begins to emit energy in the form of heat and light. Now through the entire star's life, there are many changes that take place. So if we look at stellar evolution, the life cycle of the star and the lifespan of the star depend upon the mass. If you have a smaller massed star, such as our sun, it will actually live longer than those large mass stars. Massive stars burn through their energy much faster, and so they can only live for maybe a few million years, whereas the smaller stars have their energy for a longer period of time. They can last for trillions of years. So mass is that determining factor on how long the star will live and what process it will go through. So as stars age, the amount of energy that they're generating starts to decrease. At some point, there will no longer be enough hydrogen or helium to go through the process of nuclear fusion and generate energy, so the star would no longer continue to radiate or give off that energy. So if we look at the entire process or the entire life cycle, we can see that the beginning of the stellar evolution is the nebula. Because remember, we said all stars begin in a nebula. Now what happens in that nebula is it starts to contract a little and it starts to spin. When it starts to spin, it is now creating what's called a protostar, and this is really that birth of a star phase. As it spins faster and faster and faster, it starts to really radiate that energy and it starts to glow. And this is when it becomes what's called a main sequence star. Now about 90% of all stars that we know of in the universe are in the main sequence phase of their lifespan. Now, depending upon the mass of the star, you're either going to generate into a red giant or a red supergiant. Now what's happening at this point is, as it's gone through the main sequence, it's starting to expand. So it pushes outward. As it expands, the star cools off. Again, depending on size, it's either a red giant now or a red supergiant, much larger but much cooler. And this is where the pathway differs depending upon that initial mass. Your smaller stars, the medium size, and this would include our sun, after the red giant phase, they're going to continue expanding and they're going to basically blow away their outer shell. That's creating what's called the planetary nebula, which is some of the most beautiful and colorful objects in space. After the planetary nebula, what's left is the core of the original star, and this is the white dwarf. Much smaller, very, very dense, and still able to generate energy. Now, theoretically, over time, this white dwarf is going to burn through its energy and no longer emit light. When it no longer emits light, it will be referred to as a black dwarf. Now your largest stars, those massive stars, these are going to result in a red supergiant, where it's much larger. What's going to happen is, as it expands, it will eventually explode into what's called a supernova explosion. Now, after the supernova explosion, depending upon that mass, you're going to be left with one of two things. Either a tiny, tiny neutron star will be the last remnant of the star, or the most massive, so only your largest stars can form into a black hole because they still have so much gravity left to pull it in. So it is a complete misconception that our star is going to explode. Our sun does not. Our sun, remember, is going to end up as a white dwarf. So let's look at that life cycle of our sun. So this diagram is going to show you that transition. Look where we're at now. We're at about 4.5 billion years of age. So we're about halfway through the life cycle of the sun. So we are still in the main sequence, and it's going to transition into a red giant. You see our nebula, and finally a white dwarf. So here's the process. Right now we said we're about halfway through, right? So it's been burning for over 4 billion years. It is going to continue to burn and eventually get brighter. So eventually it will no longer go through that fusion. So again, we're talking about 5 billion years here. So we've got a long time. When that happens, that outer core is going to push outward. Remember that red giant phase. It is expanding, but it's cooling off. Now, unfortunately, as it expands, it's going to get to about 3 times the size it is now, which is going to push it closer to Earth. So even though its overall temperature is decreasing, the temperatures will still be too high for survival on Earth. So it would boil the water out of the oceans, it would scorch the land, and would kill off what's living on Earth. Now remember, this is 5 billion years away. After the expansion, it will shrink back down because it's going to have the planetary nebula, and then it will end its life as a white dwarf. Eventually, when it finally burns out completely, it would become a black dwarf. So that's the life cycle of our sun. Some key things to remember: that the life cycle depends upon an object's mass, and that there are 2 separate pathways that it can take.